Dirac relativistic equation. There were shortcomings in the KG equation. A major problem was with the negative probability density. Dirac set up a relativistic equation which avoids the difficulties of negative probability density of KG equation and described naturally the spin of electrons. So Dirac look for the wave equation that is invariant under the Lorentz transformation. So to avoid this, the negative probability, what he did, he took that the equation must be linear in time, and for symmetry, he took that it should be linear with p momentum, or you can say that it should be linear in space. So for that purpose, he took px, py, pz. So we write down to avoid negative probability density this equation should be linear in time. For that purpose, what he took curly or curly t, and on account of symmetry, it should be linear in space. Hence, px, py, pz. So, the modified Hamiltonian is of the form, क्या लेंगे हम Hamiltonian हमारी C is H is equal to C alpha P beta m naught C square. This is equation number 1. Where P is momentum operator. C is velocity of light. And alpha and beta need not to be constant number. But here we have taken that these should be matrices, so they are a number but are spin matrices. Spin matrices, or we can call them spinors. do not depends upon R, P, T and E. So our eigenequation is, we usually know, H psi is equal to E psi. So in this way, what we will get, hence E C alpha P beta m naught c square psi is equal to 0. This is your equation number 2. Here the interesting factor is your psi is also a function of spin matrices, और हम इसको कह सकते हैं कि spin variable, the spin variables instead of besides your R and T. So equation 2 can be rewritten as you just put all the operator values, that is I h cut curly or curly T plus then your I h cut C alpha dot del minus beta m naught c square psi is equal to 0. You can write down this equation as 2a. If 2a equation describe a free particle there can be no terms in H that depends on space and time coordinates. Because these terms give rise to your force, so we write down, since such term would have the properties of space and time dependent energies, and that give rise to force. Also, the space and time derivatives are to appear only in P and not in alpha and beta, because we have already taken that this equation must be linear in your these derivatives. So since equation 2a is to be linear in all these derivatives, सो हम ये कंक्लूजन निकाल सकते हैं कि sorry, so we just conclude that alpha and beta are independent. किससे इंडिपेंडेंट है? इंडिपेंडेंट ऑफ आर, पी, टी एंड ई. So commute with all of them. The second part, we will proceed to find out spin of spin matrices which are alpha, beta. Now to find out these spin matrices alpha and beta, we multiply equation 2 with E plus alpha P beta M naught C square. We just multiply it by effect to this one. Or we can say that pre-multiply by this factor. So this will be E plus C alpha P beta M naught C square E minus C alpha P minus beta M naught C square, and that is psi is equal to 0. Now put the values of this alpha and P. So we can rewrite down this as E plus C. If we will find out the dot product of this alpha and P, then alpha x Px plus alpha y Py, alpha z Pz. So we round down alpha x Px, alpha y Py, alpha z Pz, and then beta M naught C square. This is your one. Second one is that is E minus C alpha x Px alpha y Py plus alpha z Pz minus beta M naught C square. Psi is equal to 0. Now multiply these two. After multiplication, what we will get? Now multiply E by E. So you just multiply yourself and just try to match with my answer. That is E square C square alpha x square Px square alpha y square Py square alpha z square Pz square, then C square common alpha x alpha y alpha x Px Py plus alpha x alpha z plus alpha z alpha x Px Pz plus alpha y alpha z plus alpha z alpha y outside Py Pz minus beta square M square 4 mc square, sorry, it is mc cube, then alpha x beta alpha x outside px plus alpha y beta alpha y, then outside py plus alpha z beta alpha z, outside is pz, and these all are equal to 0, and this is your equation number 3. So the best part of this, to remember this equation, is you just try to solve yourself and just multiply it one by one. Just multiply. The best part that you have to remember is, then always try to maintain the order of this alpha x, alpha y and alpha z, because these are matrices. So the important note is alpha x, alpha y, alpha z and beta are matrices, so their order should be maintained in the various product terms. Now this equation also valid. This equation agrees with Schrodinger relativistic equation, that is E square not C for C square P square, only if alpha and beta satisfied. There are some relations which this must follow. Following relations. First one is alpha x square, alpha y square, alpha z square is equal to 1. So what is here is how you will get this equation from your equation number 3. This equation. From this equation, how you will get that particular equation? So our equation is, you just try to match that E square M naught square C for C square P square. How we will get this equation? Means first term will be there, then M naught C की power 4, that is, which is what? This one, and this one, and then what you get? C square P square, means the square terms, this one, this term, except these all terms must be 0 at somehow. So this can be only possible if alpha x square, alpha y square, alpha z square. The best part is, I should rewrite this part again. I should rewrite this part again. This is only for the learning purpose, so that you try to match this one. So this is only for the learning purpose. So this equation will become this only when then we will have your alpha x square, alpha y square, alpha z square all are 1, and alpha x, alpha y, just try to match these two equations. Alpha y, alpha x वो इक्वल है x alpha z, alpha z, alpha x equal to alpha y, alpha z, alpha z, alpha y equal to 0. ये 0 तभी होंगे जब ये एंटी कम्यूट हो, यानी कि हम ये कह सकते हैं कि अल्फा एक्स, अल्फा वाई, अल्फा जेड क्या है, एंटी कम्यूट है। इसी के साथ साथ और हमें क्या चाहिए, m naught square c4, so it means this beta square should be 1. So next is beta square 1, and finally what we have some more terms which are alpha x beta means beta alpha x, similarly alpha y beta and beta alpha y, that should be equal to alpha z beta beta alpha z. Its all term must also be 0, and only you just try to check out that this symmetry alpha x beta beta alpha x means these are the commutative relation, so they should be 0 means they should be alpha x alpha y and alpha z जो वो क्या होंगे, एंटी कम्यूट होंगे, एंटी कम्यूट विद क्या रहा आपके पास, बीटा। सो ये सारी कंडीशन फॉलो होने के बाद दिस 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 एंड दिस, ये इक्वेशन फॉलो होने के बाद हमारे पास ये जो हमारी इक्वेशन नंबर 3 है, दिस विल बिकम दिस, it is all our equation number 4. So we can now, since alpha and beta anti-commute rather than commute with each other, hence they can't be numbers, but they are matrices. So to represent these matrices, we assume that beta is 1 0 0 0 0 1 0 0 0 0 minus 1 0 is 0 0 0 minus 1, 4 by 4 matrices. Similarly, for alpha x we will have 0 0 0 1 0 0 1 0 0 1 0 0 1 0 0 0, this is your alpha x. Alpha y 0 0 0 0 0 iota 0 0 minus iota 0 0 iota 0 0 0, this is your alpha y, or alpha z is 0 0 1 0 0 0 0 minus 1 1 0 0 0, and this your 0 minus 1 0 0, and this is your equation number 5. So these are the 4 by 4 matrices. We have assumed all these 4 by 4 matrices according to our equation, and this chapter more detailed is covered in case of your how we have selected them, it is in our quantum mechanics. So there we have assumed those purely spin matrices. So how we have taken this one, now these 4 by 4 matrices. So please take care of this one, that These matrices basically we have taken derived basically from your purely spin matrices. So 4x4 matrices evidently are Hermitian. Hermitian है, इसका मतलब ये होगा कि B dagger is equal to beta dagger is equal to beta, alpha dagger is equal to alpha x, alpha y dagger is equal to alpha y, or alpha z dagger is equal to alpha z. This, what this dagger represent? This is your transpose conjugate, your transpose conjugate. So these four matrices can be taken in the form of your purely 2x2 spin matrices. So like that beta is equal to identity I 0 0 minus I. Next is alpha. अल्फा को purely spin matrices की टर्म में लिख सकते हैं 0 सिग्मा सिग्मा 0, और alpha are three matrices, that is your alpha x. So alpha x को हम कैसे लिखेंगे? Alpha x is equal to 0 sigma x 0. What are these sigma? These are purely spin matrices. Spin matrices. So alpha sigma x क्या होता है आपका purely spin matrix में? Sigma is 0 1 1 0, that is your 2x2. Sigma y, that is 0 plus iota 0, and similarly z जो होता है आपका 1 0 0 minus 1. So these all matrices we have covered in case of your quantum mechanics. Quantum mechanics part 1, spin matrices. So also what is I here? That I is a unit matrix, that is 1 0 0 1, that is also 2 by 2. So next part will be your properties of alpha and beta matrices, that we will do.